In this video, I want to discuss the transformations of a parabola. So you'll recall that I've encouraged you to memorize f of x is equal to x squared. The vertex here would be 0, 0, and it just looks like a huge smiley face. I'm taking the function I started with, but I'm adding some h value to all of the x's. So I have this slider here, and it allows me to change values for h. And I want you to notice as h gets bigger, what's happening to the graph. The graph is sliding to the left is what you should notice. So as h increases, then that parabola, the vertex, simply shifts to the left by that h value. So for instance, if h is equal to 6, then the vertex was at 0, 0, and now it's at negative 6, 0. So if you add a negative number, so if h is negative, so if you have x minus a number, then the graph moves to the right. The next translation I'm going to talk about, these would be vertical translations. So what happens if I take x squared and I add a number? So x squared plus k, x squared plus 3, for instance. And I notice the whole graph shifts up 3. So that is exactly what we would think would happen. And that is because we're first taking the original function and adding a number on the outside. So the operation before was different. This was a composite function, and this is on the outside. That operation is taking the original function and adding to all of the y values, so it's only affecting the y values. So that's why this vertical transformation, adding a positive number moves the graph upwards, and adding a negative number, like you might assume, moves the graph downwards. So these are vertical translations. These occur when you add or subtract numbers to the outside. So I've talked about h and k here. Those involve translations, moving the graph left to right or up and down. The next thing I'm going to talk about are values for a. So a here, this constant, affects the graph by stretching the graph. So here I have a is equal to 1, so that gives me just 1x squared. If I went to graph 2x squared, then the graph becomes kind of a skinnier little parabola, a skinny little smiley face. 1/10, this gives me a very wide smile. So values for a, if they are fractions, then it widens that graph. If you have very large values for a, then it becomes a skinny little parabola. It grows much faster. Now let's talk about negative values. So you're taking this function and you're multiplying the whole thing by negative a. You're flipping that graph over the x-axis. We could also, so a has to do with stretching or reflections. So we could have also talked about y equals f of negative x, and I just need to go in and change the color here quickly. So now I want to graph f of negative x, is because this graph is actually flipping around the y-axis, but because we already had that type of symmetry, you can't even tell the difference. That's actually an identity, and I'm going to type that here. An even function has the identity such that f of x, the original function, is equal to the exact same as f of negative x. If you plug in negative x's for all of the x's, you have the exact same graph. So this is actually a definition for an even function that you might encounter sometime. Alright, I'm going to go ahead and pause this video and give you some time to practice with these quadratics.